Understanding energy balance. We first need to understand how to assess energy requirements. We need to start with a couple of definitions. Estimated energy requirements, EER, is dietary energy intake that is predicted to maintain energy balance in a healthy adult of a defined age, gender, weight, height, and level of physical activity consistent with good health. Some other definitions you will need to know. BEE, or basal energy expenditure, which is also called basal metabolic rate, BMR. This is the energy needed to carry out fundamental metabolic functions such as breathing, ion transport, normal turnover of enzymes. RMR is resting metabolic rate. This is energy expenditure under resting conditions. It's generally 10 to 20% higher than basal energy expenditure due to the effect of recent food consumption or physical activity. REE is resting energy expenditure, and this is calculated, it's a calculated estimate of REE, and it's extrapolated to 24 hours. And now a bit more terminology. TEF, which is a thermic effect of food, is the amount of energy expenditure above the basal energy expenditure, and it's due to the cost of processing food for use in storage. Basically, this is the energy used in digestion, absorption, and distribution of nutrients to the body. Total energy expenditure, or TEE, is the sum of basal plus thermic effect of food plus physical activity plus thermoregulation of energy expended in growth and lactation. And lastly, EER, which is the estimated energy requirements. You also hear it as EEE, estimated energy expenditure, or REI, which is recommended energy intake. Now, almost everybody has seen the calories on nutrition facts and knows how to read them, but many of y'all may not know the actual definition of it. The definition of a calorie is the unit of heat equal to the amount of heat required to raise the temperature of 1 kilogram of water by 1 degree Celsius at 1 atmosphere pressure. It's also called a kilocalorie. There are several methods for assessing energy needs. Some of the most popular are the rule of thumb, the dietary reference intake formulas, Harris-Benedict equations for BEE, Mifflin-St. Jeor equations, Ireton-Jones equation, and indirect calorimetry. Now, estimating energy needs using the rule of thumb is a quick and dirty way to get your energy estimation. For healthy adults, assuming a light activity, you basically take the amount of kilograms a person weighs and times it times the set amount of calories. For instance, for weight loss, you would take 25 calories per kilogram. For weight maintenance, it would be 30, and for weight gain, you would use 35. Another way of estimating energy needs is using the dietary reference intake formulas, or DRI. These formulas were derived from the doubly labeled water technique, and we'll discuss that technique in subsequent slides. There are different formulas for males and females, and it also takes into account a physical activity code. And so they apply whether or not you're sedentary, low active, active, or very active for men and women to this calculation. Of note, most people are going to fall within the low active or sedentary categories. The active is 3 to 10 miles a day of walking or running, and very active is 10 or more miles a day. So those are your extreme athletes. One way to estimate energy needs is using the indirect calorimetry method. And this is a picture of a woman that has a hood indirect calorimetry on. Basically what it does is that the pulmonary gas exchange measurements are used to determine the cellular metabolism or energy expenditure. So basically you measure how much CO2 is exhaled and how much O2 is consumed. And with the ratio of the volume of expired carbon dioxide to the volume of oxygen absorbed per unit of time gives you a calculation of how much energy was expended. Using the same concept of the indirect calorimetry, many research labs have created these whole room calorimetry chambers, which they're small rooms and it's basically airtight, and the entire carbon dioxide and oxygen consumption is measured. Same concept, but on a little bit bigger scale. This is supposed to reflect a little bit more of free living. And as you can see from this picture, many times there's a place for the person to eat, there's a place for the person to exercise and to sleep and to relax. Obviously, this gets a little closer to free living, but we don't live in small rooms, so it's not as accurate as you might think. It does give us an estimate of how much energy we can burn doing certain types of activities, though. Doubly labeled water is another technique used to estimate energy needs, and it's still considered the gold standard. It was actually developed about 50 years ago, and about 30 years ago became much more popular in research settings. It does measure total expenditure over several consecutive days in a free living person. So instead of having them sit under an indirect calorimetry hood, this is measuring them when they're in their daily life. Subjects ingest a dose of doubly labeled water, which is 2 stable isotopes, deuterium and oxygen-18. And in order to do the calculation, you have to collect a series of urine collections, where it is possible to compute the CO2 production rate which is the difference between the isotopes. An important thing to note is that it does not measure food composition. It simply measures energy expenditure. And when compared to reported intake, research does show underreporting anywhere between 10 to 50% for adults and 10 to 30% for children. So it definitely shows us that this is a better method as compared to self-report, and it also highlights the fact that people often underreport. What does energy balance really mean? And it's pretty simple. If you eat more food or energy or calories, whatever you want to call it, then your body will burn, then you will gain weight. And so this doesn't, really matter as much on the type of food that you're eating. So for instance, if you were to eat, 3,000 calories of watermelon per day and you only needed 2,000 for weight maintenance, this would result in weight gain. Similarly, if you were to eat 800 calories of Snickers bars, which really is probably 2 Snickers bars per day, you would probably lose weight. So one way to think of it is that 1 pound of fat equals 3,500 calories. So if you eat an extra 3,500 calories a day and you don't burn it off, then you'll gain 1 pound of fat. If you exercise less than usual and don't burn 3,500 calories, you'll also eat 1 pound of fat. And with holidays especially, we typically eat a little bit more calories, and it does result in slight weight gain. Obviously, this kind of calculation doesn't take into the fact other roles, such as genetics, muscle mass, thermic effect of food, and compensation with energy intake and output. Many times, even if we eat more, chances are our activity will go up. Or we might eat more at one meal, and subsequently at our next meal we'll eat less. So sometimes our body does the natural balance on its own. But the concept is really to look at pounds of fat lost. If you're really wanting to lose 2 extra pounds, it's pretty simple to calculate exactly how much energy you'll need to expend or how much less energy you'll need to consume. So in research, particularly obesity-related research, we need to have good ways to measure dietary intake. And unfortunately, there's not a lot of objective ways. The methods that we often use are called the 24-hour recall, which is probably becoming more and more the gold standard, 3 or 7 day diet records, weighed records or recalls. This is where the participants take home a scale and actually weigh their food and record it. Food frequency questionnaires, and there's a whole bunch of different ones out there, and this is basically asking what you ate and how much of it you ate over the past week or month, or there's one that's actually over the past year. Observational methods, this gives us a little bit more of an objective method, and this is like if you were to record and observe kids at a cafeteria and record what they ate. Plate waste is similar, as you can do an observation and you can actually have them turn in uneaten food, and then you could calculate the amount of intake that they consumed based on what was served and what was not eaten. A lot of different tools in order to get better accurate measures. We use food models a lot of times in research. These are basically fake plastic models of food. There's big 2D books that give you the actual serving sizes. Measuring cups. This is sometimes we hand measuring cups out to our participants and have them estimate based on the amount that's in the cup or the serving size that we give them. Or you can also use common objects. For instance, a deck of cards equals 3 ounces of meat. A tennis ball is the size of a medium apple. As I mentioned, the 24-hour recall is probably becoming the most popular. And oftentimes it's referred to as the multiple pass approach. So multiple pass 24-hour recalls. You'll start to see a lot of that in the literature. Even some of the national epidemiology studies suggest this is the best way. And what this is basically asking what the participant ate or drank yesterday. So you're only asking them to remember one previous day. And it's a technique that you can do it in person, or you can actually do it while entering into the computer. And there's several passes, and you guys are going to practice this in class. The first pass is very general, and you simply ask the participants what they had after midnight, the previous night. What was the first time you had something to eat or drink? And at that time, what did you have? And did you have anything else at that time? You're basically just trying to jog their memory on the different time points in the food and beverages that they ate or drank. The second pass, you go back and you review. So you say, at 7 o'clock, I see you had cereal. Can you think of anything else you had at that time? And they may say, oh, I had orange juice with the cereal. Did you have a beverage with that meal? These are some prompting questions. Did you have any snacks between the meals? So you're basically going back to the initial list, seeing if they forgot any foods. You're not getting any information yet about those foods. The third pass is where you obtain the detail. And so you ask, what were the ingredients? Did you have condiments? Did you have ketchup on your hamburger? What was the portion size? Did you add sugar to your coffee? And this goes back to think about, how we typically eat and drink things. If they had a Coke at Dairy Queen, did it have ice in it? Most likely it did. So this is getting more detail. The dietary software most often used for 24-hour multiple pass recalls is the Nutrition Data System for Research, or known as NDSR. It was developed by the Nutrition Coordinating Center at the University of Minnesota. It uses a comprehensive source of food composition information and includes over 18,000 different foods, including 7,000 different brand names. It gives you lots of different output files. It gives you all the nutrients, the vitamins, minerals. It also calculates food servings. It also has an output file that looks at meal timing. It often takes about 20 to 30 minutes to collect each recall. It's immediate data storage and immediate analysis. So right after you enter a recall, you can actually export it and get all the data you could possibly need on it. There are prompts set up with the recall on the system to make sure the data is correct. And so it's kind of like there's data cleaning steps as you go, which is a really nice feature. But I do want to point out that this is a very expensive software. It's around $11,000 for one license, and the annual fees are around $2,000 to $3,000. There are other dietary softwares that you can use for research, and you can even use them to enter your recalls. These are basically just softwares that you purchase, and they have access to the same kind of national food databases where you can enter the food. The difference is that it's not set up in a recall format. So it's not set up with the same kind of prompts and the same checks and balances. But they're cheaper usually, and you can definitely collect like a record on paper and pencil or a recall and then enter it later. I do want to mention there is the automated self-administered 24-hour dietary recall, also referred to as the ASA 24. It was released by NCI, National Cancer Institute, in 2011. It has been validated, and it's available online. It's actually a link that you can have your participants go through, and they fill out the recall online, and then you send off for the data later. A lot of investigators are using it. It has a lot of potential. There's still some pitfalls. Specifically, it's not great for low-income areas. It's a little bit harder to understand. I've taken it, and it was not as intuitive as you would think. They also recently came out with the ASA 24 for kids in 2012, but it's only validated for kids over 10 years of age. You can't use it for younger. They're not going to be able to understand it. Here's an example of a food recall that we use in our research. If we're not able to do it on the computer, on the NDSR system, on a laptop, we'll collect the food recall using the same method and then enter it into NDSR later. The one caveat is it takes time to collect it and then you have to enter it, so it pretty much doubles your time in collection. With any dietary assessment tool, you have to kind of consider other things, and you need to make sure you get adequate, you obtain from the participants adequate portion size. You want to know how many cups or tablespoons or fluid ounces. Those things can really make a difference in your nutrient output. For instance, if somebody were to, enter 16 ounces of soda or Coke and didn't put ice in there, that's probably about an 80 or 90 calorie difference. You want to ask dimensions. If you're having a brownie, you want to know the length, the width, and the thickness of it. If you can have your participant talk about a shape that it's like, it'll give you an idea for a portion size. Since we do a lot of recalls over the phone, if we can use things that are in their home to estimate the portion size, this is very helpful. Count. If they had pretzels, how many? You want to be as specific as possible. Preparation technique. If they had chicken breast, did they have the skin on it? Was it fried? Was it grilled? Ingredients. If it's a food, we have a lot of culture dishes in our research, and I want to know what type of ingredients are in it. If they say they have pozole, which is popular it's a soup in the Mexican culture, I want to know exactly what they put in it, because it's made with all sorts of different stuff. And of course, the additions, the condiments and the sauces and the butter, those can really increase the sugar, fat, and calorie content. So you want to make sure you obtain those as well. So let's talk about the strengths and weaknesses of certain dietary assessments. And I'm going to use the 24-hour recall when we discuss this, but you'll see that many of these strengths and weaknesses apply to any dietary assessment method. The strengths is that it's fairly, respondent burden is small. You're asking them to commit 15 to 20 minutes of their time to tell you what they ate yesterday. Most people will do that. We have to incentivize them a little bit, but they'll typically agree to doing this. And they also I find that a lot of participants don't mind telling you what they ate. People like to somebody is interested in the details of what they ate is interesting to them. Administration time is relatively short. Like I said, it takes 15 to 20 minutes, sometimes longer depending on how much they ate. Time period is defined. You're not asking them to remember what they had over the past week or month. You're asking them to just remember yesterday, and typically people can do that a little bit better. Food intake can be quantified. So unlike a record that they turn it in, you can't, people write down bowls of cereal or a pizza. With so little detail, you can actually get all that detail right then and there. It is suggested that you at least collect 2 or more days to provide data on intra and individual variation. 3 days is considered the best, 2 weekdays, 1 weekend, but 2 days is often accepted in research. Certain weaknesses, as you can imagine, it's dependent on self-report. So people have to remember what they had, so they may not be able to remember. There may be respondent bias, especially in the overweight obese population. They may not want to tell you that they ate 3 Snicker bars yesterday. And so we definitely see that underreporting is much more prevalent in the overweight or obese populations. It does affect intake. Research has shown that if you write down what you eat, it impacts what you eat. So if they know they're going to you're going to call them and ask them what they ate, they may choose to eat less on that day or healthier on that day. Data entry and cleaning is somewhat time consuming. Even though once you enter it, we have to go back and check it to make sure it's correct. The kind of cleaning process of the data analysis on the backside is pretty intense. So all in, each recall, even though it just takes you 20 minutes to administer, it could take you up to an hour to clean everything. So we also need to have ways of measuring physical activity. There are a little bit more and objective measures for physical activity assessment. The most common is still self-reported questionnaires and recalls. The diary method, where you ask participants to write down everything they did, exercise, all their activity they did for the past 3 days or 7 days. There's also the 3-day physical activity recall, which it's basically a structured format where I ask you in chunks. It divides the day in 30-minute increments, and it asks you to remember exactly what you did in those 30-minute increments for the past 3 days. And similarly, they have a 7-day physical activity recall as well. There are a lot more objective measures in physical activity assessment. A really inexpensive, cheap one is pedometers, and probably everybody in this room has experimented with a pedometer at some point in their life. Measures the amount of steps. What's nice about a pedometer is it gives you immediate feedback, so it's really useful like in goal setting or to motivate people to exercise, give them goals, have them reach it. Probably more common in research settings is the accelerometer, and there's two different kinds. Well, there's many different kinds, but two different types. Our models are uniaxial or triaxial. The uniaxial is similar to the pedometer, it just measures kind of up and down movement. The triaxial one measures movement on all the planes. So it measures up and down, or if you twist, it captures more activity. There's also energy expenditure from the whole room calorimetry, which we've talked about. There's observation methods. So if you want to, observe kids' playtime at recess or during PE, you can actually count, and there's different tools set up where you count the amount of times that the kid did, squats or walked, or you can count moderate, vigorous activity bouts. Obviously, it's time consuming, and it takes a lot of staff to do so. In addition, you can measure fitness, not physical activity, what they're actually doing, but you can measure how fit they are, how, you can do VO2 maxes, which I'll show you on a couple slides down the way, shuttle run tests, or you can just measure heart rate. And finally, you can measure strength. Probably the most popular one is to do a 1 repetition maximum, and I'll show you some of those examples on further slides as well. So here's a picture of an accelerometer, and as you can see, they're very small, much smaller than beepers. And this is an older model, but this one is actually waterproof. And it basically has one button, and so the participants can't see what they're doing. They typically give you a band and a little pouch so you can wear it around your waist. You can also attach it on a clip to your jeans or something along those lines. You can wear them in the water, and now they're actually making them, the newer models, so that you can wear. They have longer memory, and you can wear them at night, so it can measure sleep as well. And the output that the accelerometer gives you there's several different things. It gives you counts per day, and then it applies certain cutoffs using algorithms that they've calculated to estimate different intensity levels. And specifically, it'll let you know how many minutes or bouts that a participant spent in light activity, moderate activity, heavy activity, and very heavy activity. It also gives you an estimation of how many calories were burned. And before, what we had to do is we would give a participant an accelerometer. They'd wear it. We asked them to wear it for 7 days, and then they'd come back and they'd give it to us, and we download it to make sure they wore it. Now the accelerometers are actually Bluetooth to our software so that we can see exactly how many days and minutes a participant is wearing it. And it's real easy to see non-wear time. So if they're not meeting, they haven't worn it 7 days, at least 10 hours a day, we can basically send them a text message or call them and say, hey, we noticed you weren't wearing it. Can you try to wear it? We can incentivize them if we need to, encourage them to actually get to wear it so we can get better data. So this is an example of the output that we get. And so you can see the date, it has the person, the ID, has some of the kind of specific demographics, and then it plots out exactly how active they were over a time period. And like I mentioned before, it appears that some of these things that are in red are really more of the ones that probably were non-wear time. They took it off, took a shower, or went swimming, something. Even though they're waterproof, a lot of participants still don't like to wear them in the water. But then they apply certain cutoffs, and you can actually calculate how many minutes were spent in different types of activity. I will also want to mention that the later accelerometers can store up to, I believe, 32 days worth of data. So let's talk about some strengths and some weaknesses to accelerometers. The strengths is it's an objective and it's a quantitative measure. It doesn't rely on self-report. You're basically, you get a fairly accurate measure of what they're doing throughout the day. They can't modify that. They have no way of breaking into it to change it. Now, I will say that some of our participants have put it on their dogs before, but it's pretty easy to tell when that's not an actual person because it's moving all over the place. It can store up to weeks worth of data. Participants can't see the data, so should not influence the behavior. Now, in an intervention, if you're trying to influence the behavior, this may be a con. But for the most part, in research, we want to know exactly what's happening in response to a different type of intervention, or just cross-sectionally, or over time. So we don't want them to be able to look down and say, "Oh, I've had 10,000 steps today. I need to do more," or vice versa. So they don't have any idea what the data is telling us. It's easily downloadable, and data is stored immediately and entered. So you don't have to go back and enter anything. With a lot of the questionnaires, you have to go back and upload, and spend hours and hours of data entry. And as I mentioned before, this is all Bluetooth now, so we can actually get the data remotely and see if a participant is actually wearing the accelerometer for the time period that we have asked them to. The algorithms that have been done and validated assess the intensity cutoff, so we get very nice data on the minutes and bouts spent in different intensity levels. And it can easily determine non-wear time. So, I know right from looking at it, if I see hours of just nothing, even if you were sitting still, you're likely going to get up to go to the bathroom, or you're going to move around, so you'll see little blips. So non-wear time is fairly easy to determine. As far as weaknesses, it's relatively expensive. It's around $325 each, and the software is around $1,200. They can get lost easy. We always have to account for, at least 3 or 4 of them getting lost. Subject burden. It's asking someone to wear something on their body for 7 days, sometimes longer. And a lot of times participants don't mind it, but it is kind of a nuisance. And subjects take them off and forget them to put it back on before. And a lot of the models that we have, we still have to reissue them. Now we can just text them and call them and say, "Hey, you need to put it on," or figure out ways to incentivize them while they're out in the field. We can also measure physical fitness, and the most common way is using the VO2 max principle. And this is the way of measuring the maximum capacity of an individual's body to transport and use oxygen during incremental exercise, which reflects the physical fitness of the individual. And if you look at this diagram, this shows you it's similar to the concept of the indirect calorimetry, measuring amount of the oxygen consumed and amount of carbon dioxide that is produced. The VO2 max can be done by using a treadmill, stair climbing, walk test, or even a stationary bike. Just depending on the overweight or obese status or even athletic ability of the individual, you might want to use something a little bit less intense, like a walking or a bicycle test. But basically, you place the indirect calorimetry mask, similar type, just not all over their face, it goes straight over their mouth, to measure the amount of oxygen that's consumed and carbon dioxide that's produced. And you start by walking at a low speed, at a 0 grade, and you basically increase the speed and inclination, or both, at regular intervals. The subject is breathing through the two-way valve, and sensors measure the O2 inhalation and CO2 production. And with this, they come up with an equation. Ideally, the oxygen consumption will completely flatten out despite ever-increasing workload, and this is considered to be your VO2 max. There are also ways to measure physical fitness when out in the community or school setting. You obviously can't do a VO2 max on all schools' children. Probably the most common is the shuttle run test. And you may have done this when you were in high school or in middle school. Basically, you set up a series of cones, and the objective is to run between the markers and the time. And there's an audible indication, whether it be a bell or a ting or some sort of timer. And each minute, the time duration between the beat decreases. So you have to increase with the pace in order to get done with the test. So you basically measure how many stages that you pass. Each stage lasts back approximately 1 minute with a total of 20 stages. So if you get through all 20 stages, that's considered to be extremely physical fit. So in order to do the shuttle run test, you need an observer or several observers that have this kind of checklist. And you're basically counting how many stages and how many runs each participant can get through in the amount of time when you record this. Typically, if you have a class of 20 or 24, you're going to want at least 3 3 or 4 observers to be able to kind of write this down. So it still takes a lot of manpower, but you can do it fairly quickly. So many interventions also look at the effect of a strength training program, for instance, or you want to do a cross-sectional and just look at straight strength. The most common measure is called a 1 repetition maximum, and usually it's a chest press and it's a leg press. And so you basically keep putting on the weight and see the maximum amount they can lift at one time. And so they have to be able to get it all, get through 1 to be able to count it, and they get up to 2 tries to be able to do this.